Last lesson, we have introduced the interest rate swap and the valuation of which at the time point when the payment is just swapped. In this lesson, we're going to deal with the case for any given time point. Let Ti be the time when the I's payment from now is exchanged. Let K be the fixed payment made on each payment date. Let Ri denote the floating rate corresponding to the maturity Ti with continuous compounding, and Fi be the corresponding floating payment made at time Ti. Recall that we have shown in the previous lesson, the floating rate bond is identical to a newly issued floating rate bond immediately after a payment date. That is, the value of a floating rate bond is equal to par at any reset time point. Then, between payment dates, say at a time where the time period to the next payment date is T1, the value of the floating rate bond is the current value of the principal N plus the floating rate payment F1 to be made at time T1. The discount rate used here is R1 correspondingly. The evaluation of the fixed rate bond is straightforward. That is, the sum of the present values of the fixed payments made at each time point Ti. Note that at the last time point, we have to include the bond principal N. Then, the value of the swap to the company receiving fixed and paying floating is given by the value of the fixed rate bond minus the value of the floating rate bond. Now let's take a look at an example. Suppose that a financial institution has agreed to pay a 6-month floating rate with continuous compounding and receive a fixed rate of 8% per annum with semi-annual compounding and a notional principal of $100 million. The swap has a remaining life of 1.25 years. Given the floating rates for 3 months, 9 months, and 15 months maturities are 10%, 10.5%, and 11% respectively, and that the 6 months floating rate at the last payment date was 10.2%. Determine the current value of the swap to the institution. First, since the fixed rate is 8% per annum with semi-annual compounding, we have K equals to $4 million. And the 6 months floating rate at the last payment date was 10.2% with continuous compounding. We can get that F1 is equal to $5.23 million. Here's the timeline with the cash flows indicated. Then, we can calculate the value of the fixed rate bond, that is, the sum of the discounted cash flows in blue. The discount rates used are the 3 months, 9 months, and 15 months maturities floating rates respectively. The floating rate bond value, as we have analyzed earlier, is the discounted sum of the principal and the next floating payment F1. Since the institution receives the fixed rate and pays the floating rate, the value of the swap to it is value of the fixed rate bond minus the value of the floating rate bond, that is, minus $4.3962 million. Up to now, we know how to evaluate an interest rate swap. The next question is, why do we introduce such kind of financial instruments? In practice, companies use interest rate swaps to modify their interest rate exposure. Recall the earlier example of a swap between companies A and B, where A agrees to pay B a fixed rate of 5% per annum and in return receives from B 6 months LIBOR on the same notional principal of $100 million. This swap could be useful to either company in the scenarios described as follows. For company A, suppose it has arranged to borrow from a bank $100 million at LIBOR plus 10 basis points. Together with the interest rate swap arranged with company B, now A has 3 sets of cash flows. First, it pays LIBOR plus 0.1% to its bank. Second, it receives LIBOR from B. This is from the arrangement of the swap. Third, it pays to B at fixed rate 5%, which is also from the arrangement of the swap. These cash flows net out to an interest rate payment of 5.1%. This swap thus has enabled company A to transform a floating rate borrowing at LIBOR plus 0.1% into a fixed rate borrowing of 5.1%. For company B, suppose it has a 3-year $100 million loan outstanding, on which it pays 5.2% interest rate. Combined with the swap, it also has a set of 3 cash flows. First, it pays 5.2% to its outside lender. Second, it pays LIBOR to A. Third, it receives 5% fixed rate from A. These cash flows net out to an interest rate payment of LIBOR plus 0.2%. The swap has enabled company B to transform a fixed rate borrowing into a floating rate borrowing. Therefore, an interest rate swap helps to transform liabilities. The reason for doing so is that in practice, companies may have their particular needs in fixed rate borrowing or floating rate borrowing. However, they may be less competitive in the one they need than the other. By arranging a swap with another party who has opposite preference, can save interest costs for both parties. We will talk more about this and how the corresponding arrangement can be carried out in the next lesson.